So the mole, really important unit in chemistry. And just to recap here, this Avogadro's number of particles is equal to 1 mole. 1 mole of an element or a compound is equal to the molar mass in grams. And so this gives us some relationships that we can convert units for. And so we can start with particles and find grams. We can go from moles to grams or grams to particles. We can do lots of things. And the conversion factors come from this relationship. So it's very important. How do we get these unit factors? Well, let's look at water. The molar mass of water is 18.02 grams. So let's just write some unit factors that relate grams, moles, and molecules of water. So how about one that's grams on top and moles on the bottom? One mole is equal to the molar mass in grams. They give us that. 18.02 grams is the mass of 1 mole. So then we can write a relationship here, 18.02 grams over 1 mole. Remember, unit factors, the denominator is equal to the numerator. They look different, but they are different ways of stating the same quantity. And so when we multiply by this unit factor, we're not changing what the value is. You know, if you take a distance in meters and you convert it to centimeters, it's still the same distance. Just the number and the unit have changed, but it still represents the same thing. So 18.02 grams per mole. We can also turn that upside down and put 1 mole on top and 18.02 grams on the bottom. And which one we use depends on whether we're converting from grams to moles or moles to grams. What's the relationship between moles of water and molecules of water? Let's put moles on top and molecules on the bottom. One mole is Avogadro's number of molecules, which I didn't quite leave room for, but we could squeeze it in here. 1 mole is Avogadro's number of particles. That's using this one is equal to that. These first two, I used 1 mole equal to this. Could we also go directly from grams to number of molecules? We could. So for water, this specific example that we're doing here, and let's just call these molecules because that's what they are. We're saying that Avogadro's number of molecules equals 1 mole of water, which equals 18.02 grams of water. Therefore, 18.02 grams is equal to Avogadro's number of molecules. To make a unit factor, you just need 2 quantities that are equal, and you can put whichever one you want on the top, and you put the other one on the bottom. So we could also have molecules on top and grams on the bottom. And it would be Avogadro's number of particles, molecules, is equal to 18.02 grams. Because if this equals this and this equals that, then the 2 things on the end are also equal. So Avogadro's number of molecules is equal to 18.02 grams for water. Any questions? What's the mass of 8.25 moles of helium? Well, what unit are they giving us? Moles. And what unit are they asking for? Mass. Okay, so they're not giving us a specific unit. What's a common unit for mass? Grams. Usually grams works the best. Do we know a relationship between moles and grams for helium? We just have to look at the periodic table, right? Because on the periodic table, the number under helium tells us the mass in grams of 1 mole. So we can do this in one step. We can take 8.25 moles of helium, and we're going to multiply by a unit factor with grams on top and moles on the bottom. And how do we know to do that? Well, we identified where we started and where we need to go, and then we put those units in here so that the units work out. Unit analysis is analyzing the units. The units tell us what to do. We don't have to remember, oh, well, to convert this to this, I multiply by that, or I divide by this other thing. We just put the units in, and then we look and fill in the numbers. Relationship between grams and moles. Molar mass, the mass of 1 mole. So it's always 1 mole. And helium, is helium a diatomic element? No, it isn't. Hydrogen is the H in horses need oats. Helium is not diatomic, so it's just the atoms. And so we just read the number off the periodic table. It's 4.00 what? 4.003 we'll call it. 4.003. It's a little confusing in this room. We have 2 different periodic tables. So we've got 8.25 times 4.003, and this is our final answer. The number we were given has 3 significant figures. This one has 4. This is not exact, but the 3 is the smaller, so we'll round our answer to 3, and we'll call this 33.0 grams. How many moles are present in 355 grams of water? Well, what unit do we start with? We start with grams. See, they gave us a number of grams, so that's what we're going to start with. So grams, and they're asking us to find how many moles, right? The relationship between grams and moles is the molar mass. So 355 grams times, and we're going to have moles on top and grams on the bottom. So the units cancel out. To calculate this, it was given on the previous slide, but we'll pretend that we don't remember that. H2O is the formula for water. So we take 2 times the mass of 1 mole of H, hydrogen, and 1 times the mass of 1 mole of oxygen, and that comes out to 18.02 grams, is equal to 1 mole. 18.02 grams, and so 18.02 and the grams go together, and it's 1 mole. So 355, this time, 355 divided by 18.02. And this would also have 3 significant figures, so 19.7 moles. .355 grams of water is about the amount of water in a 12-ounce can of soda. So there's about 19.7 moles of water in a can of soda. Any questions? What's the mass of 7.75 times 10 to the 22nd formula units of lead-2 sulfide, PBS? Remember, formula unit is the word we use instead of molecule for ionic compounds, because they don't technically have molecules. But we can treat this just like molecule. It's how many of these formula units. So this many formula units, each of them is going to have one lead and one sulfur ion in it. And this is saying how much would that weigh? So what unit are we given? Formula units, right? Darn it. Formula units. I always forget to press the pen button and then I start writing and it just doesn't work very well. And what unit are they asking us for? Grams, mass. So let's think about this. There's two common ways to do this. We can do it in one step or we can do it in 2 steps. I think 1 step is nice because it's shorter, right? So let's think about this relationship. Grams, what can we relate grams to? How do we find out the mass of some amount of lead sulfide? We're going to use the periodic table, and if we look in the periodic table, we could calculate the mass of 1 mole, right? So we could say, well, 1 mole of lead sulfide is going to be the mass of lead, which is 207.2, plus the mass of sulfur, 32.07. So 1 mole equals, we could do that in our heads, but you know, the actual calculator is generally more reliable. 239.27 grams. Now, does this let us convert from formula units to grams? No, this is moles and grams, right? But what does a mole equal in terms of formula units? 6.02 times 10 to the 23rd formula units, right? So mole is a counting number. So this is equal to Avogadro's number. I'll call this F units. If 1 mole equals this amount in grams and this many formula units, we could use these 2 guys right here as a conversion factor, right? A unit factor. So there's our relationship between formula units and grams. So now we can start 7.75 times 10 to the 22nd formula units times, we start with formula units, we want to end up with grams. So grams needs to go in the numerator and formula units needs to go in the denominator because we want the units to cancel out. What number do I put in front of grams? The 239.27. I should have underlined, this would have 4 sig figs. So I'm going to underline that just to remind myself that actually has 4 sig figs. And then down here, what do I put? Yeah, Avogadro's number, 6.02 times 10 to the 23rd. You need to memorize Avogadro's number. You'll probably do that inadvertently just because we end up using it so often. So now I need my calculator. So we're going to take 7.75 EE22, and I'm going to multiply by 239.27 and divide by 6.02 EE. I pushed the wrong button. EE23. Okay. I screwed up on my calculator. Somebody tell me what the answer is. Pardon me? 30.8? And the unit there would be grams. Anybody else get 30.8? Good. Okay. I ended up with like 3,000 because I pressed random. And I think I generated a random number. Oh, bless you. Bless you. A real calculator. It seems like I always forget something. Yesterday, I forgot my keys. I've forgotten my lunch. So forgetting the calculator, no big surprise. Any questions about that one? So that's doing a calculation like that in one step. Here's a similar one. Oh, this is going to make me crazy. There we go. But it's, silly thing. Okay, it's white now, whatever. At least it's pointing in the right direction. How many molecules are found in 0.175 grams of fluorine gas? So what unit are they giving us? Grams. And what unit are they asking for? Molecules. So again, this is one that could be done in one step or two steps. I'm going to show you the two-step method. And which way you do it just depends on how your brain works. Whichever one makes more sense to you, they are both entirely correct. So, relationship between grams and molecules. You're like, I'm not so sure about that. But we just were learning about the relationship between grams and moles. So what if I put moles in the middle here? Grams to moles is using the molar mass. And moles to molecules is just using Avogadro's number, right? So let's set this up, 0.175 grams. This is going to be in two steps. So I'm going to go to moles here, and then I'm going to go to molecules. Putting the units in first. I put grams down here because I want them to cancel out. I put moles down here because I want them to cancel out. Now I find the numbers to put in. Relationship between number of particles, the molecules, and moles. That's just Avogadro's number. Mole is the chemist's dozen, so we've got 1 mole and Avogadro's number of particles, molecules in this case. Relationship between grams and moles we get from the chemical formula and the periodic table. Fluorine gas, fluorine is an element. Is it a diatomic element? Yes, it is. So the molar mass for fluorine is 2 times the atomic mass. So 38.00 grams is equal to 1 mole. So I'm going to have 1 mole and 38.00 grams. 0.175 divided by 38 times 6.02 EE23 equals. I didn't really leave enough room. I'll write it down here. This would get rounded to 3 significant figures because of the 0.175. 2.77 times 10 to the 21st, and the only unit left standing is molecules. So that's the number of molecules in 0.175 grams of fluorine gas. Any questions? These calculations that we're learning today are critical for chemistry. This needs to become just a don't even have to think about it thing in order to be successful in Chem 1A. And that's what we're all trying to prepare to do, right, is be successful in Chem 1A. So this is really, really important. Here's a little bit of a different question. What's the mass of a single molecule of hydrogen? I should have been a little more specific. What's the mass in grams of a single molecule? We can look at the periodic table and figure out the mass in atomic mass units. A molecule of hydrogen is H2, right? Because hydrogen is a diatomic element. And so 2 times 1.008 will give us 2.016 atomic mass units is equal to 1 molecule. See, I wish that had an abbreviation. What else does this number tell us? What if we did that in grams? That would equal what? 1 mole. But they're asking us for a single molecule. I'm going to do this question a slightly different than what your textbook does. You had a question? No? So a single molecule, how many molecules is that? Just 1. So I'm going to say that is our starting value. We want to find the mass of 1 molecule. So we're starting with molecule, and we want to get to grams. Do we know a relationship between number of molecules and grams? Yes. What is it? Well, we know that 1 mole is this many grams. How many molecules is 1 mole? 6.02 times 10 to the 23rd. One of these days, I am going to make up my own abbreviation for molecules. Way too long. So could we go directly from 1 molecule to grams? Yeah, we could. Fabulous. There, we're back. 6.02 times 10 to the 23rd molecules is equal to 2.016 grams for hydrogen. So I'm going to do 1 molecule, and I'm going to multiply by grams and divide by molecules. Molecules cancel out. 2.016 grams is equal to Avogadro's number of molecules. Oops, lost the 2 there. That 2 is really important. So I've got 1 times 2.016 divided by 6.02 EE23 equals how many significant figures should I round this to? A single molecule. 1 molecule. How many significant figures does that number have? I say that would be considered an exact number, right? 1 molecule. How many sig figs in 2.016? 4. And how many in 6.02 times 10 to the 23rd? 3. So I'm going to round my answer to 3 significant figures. 3.35 times 10 to the minus 24th grams. That is a very small number, isn't it? Are we expecting a small number or a large number for the mass of 1 molecule? Very, very small. Any questions? That's the end of that section. Yeah, so let's take a break.